Okay, it's 9:05. We can get started now. Um, hey everyone, welcome back. This is session two of the MOI Builders series, and today we're going to be talking about native assets in MOI and your first token. I'm Aditya. I am the dev at Server Labs. So let me recap by talking about what we discussed last week. So last week we deployed our first logic, and today we're going to be deploying our first native asset, a real fungible token plus a real custom asset with policy logic, both live on the devnet by the end of the year. Let's get into it. So, quick callback before we go any further. Because today's session builds directly on last week, in session one, the idea I asked you to carry was this: MOI is participant centric. Every participant on the network owns their identity and owns their own state. Last week, we saw it with Flipper, moving state from one shared map into per actor storage, unlocked parallel execution. The lesson was simple: when state changes don't share or compete for state, they don't essentially compete with each other. And today we're going to be talking about the same idea of parallel execution and lack of global ordering, but applied to money and tokens. A token transfer on most chains writes into one shared contract storage, everyone in the same line. A token transfer on MOI, however, writes only to the sender's and the receiver's own state, as we discussed last time. It's the same lesson with a new attack surface. And by the end of the hour, you will have shipped a token that proves it. And then we'll do something more interesting. We'll write a custom asset with our own rules in about just 20 lines of Coco code. Yeah, and the protocol still owns the accounting underneath, which is the most crucial part of what we're going to be talking about. But this is just a quick preface. We'll get into the details soon. So in today's session, we're going to have 7 things in order. First, the why native matters, why native assets matter, what makes MOI's asset model structurally different from Ethereum's, then a quick map of the 4 standards. We've got MAS0, MAS1, MAS2, and MASX. After that, we're going to have a first demo. We'll create and mint a standard fungible token on our devnet with just one SDK call. Then we're going to have a bridge slide on why you would ever need a custom asset logic in the first place. And then we're going to have a quick demo, which is essentially a tax token, which is built in Cocola and deployed via the SDK we used last week. And we'll fire a transfer to watch a 5% cut happen on chain. And yeah, and one more very interesting thing we have today. For the 2 demos we have a small bounty of sorts. There's a Google form at the end you can fill out before Sunday. But essentially, if you follow along with the code, and if you deploy the code yourself, you will be entitled to receive some MOI tokens. And yeah, more details at the end. And always questions in the chat at any time. I'll watch and answer as we go. Let's get into this. Okay, so here's the structural insight that makes everything else in this session work. On most blockchains, a token is just a contract. It's a smart contract you deploy with a mapping inside it called balances. And that mapping pretends to be balances. The protocol itself doesn't know about your token or your asset. It just sees contract storage that your Ethereum wallet happens to interpret. ETH is special on Ethereum because it's the only thing the protocol natively tracks. Everything else, every ERC20 contract, every NFT is fiction maintained by an application developer. And there's a real consequence to that. Think about why honeypot tokens exist, honeypot attacks happen. On Ethereum, you can't have a honeypot attack on ETH because it has no attack surface. The protocol owns it. But every ERC20 is an arbitrary user code. The developer can write a transfer that always reverts. They can write a balance off that lies. They can hide a backdoor that drains holders' tokens. That whole class of attack only exists because tokens are code on Ethereum and they're stored within almost centralized mappings. MOI, on the other hand, inverts this model. An asset is a first-class protocol object, meaning the network understands what an asset or a token is the way a programming language understands what an integer is. It's a native concept, not a pattern someone agreed to, and the consequence is huge. Every MAS0, every MAS1, and every MAS2 asset is honeypot proof in the same way that the ETH token on Ethereum is. The transfer code is the protocols, and no one wrote it. No one can lie in it. And finally, for MASX, the custom master standard we'll see in a few slides, the developer does write the policy, but even then, the engine still owns the accounting underneath. A hostile MASX dev can restrict who's allowed to transfer. They can't create negative balances, can't exceed the supply cap, can't break atomicity. The blast radius is way smaller just by design. And yeah, here's the structural part. On the left, we have the asset object. Um, this is essentially the global blueprint, class definition if you're an object-oriented person. It holds the symbols, it holds the decimals, the max supply, who the manager of the asset is, its metadata, and this object only lives once in a dedicated asset account. And critically, during a normal transfer, the object is read-only. The protocol references it for validation but doesn't touch it. It only changes for mint, burn, or any manager-driven actions. On the right, we have the token object. Now, this is your actual balance, your actual ownership. And this is the part that's different from anything you used before. It lives inside your own participant account in something called your asset tree. Every participant has their own. For example, Bob's balance of a token lives within Bob's account. Alice's balance of the same asset lives within Alice's account, not in a shared mapping within a smart contract. And yeah, essentially the underlying point to take from this slide is the fact that the blueprint is global, but the ownership is local to each individual and each participant. And that separation, class up there, and instance or ownership, separating ownership with the blueprint is what makes everything else in the session possible. And just hold on to that thought. We're gonna dive deeper into it. Okay, so what does that separation actually do? Let me show you side by side. On the left, this is essentially how a USDC transfer or any token transfer works on Ethereum. We have three characters, Alice, Bob, and Carol. Three users moving tokens. Now, where do all of these three state changes go? They all go into the same place. All three transfers are editing the same USDC mapping. They specifically go into the USDC contract's internal storage, and the balance is mapping inside one specific contract. There's one storage tree, one root, and three state changes funding in. When the network is busy, every USDC user in the world is contending for the same bytes of state, which is what essentially causes the global ordering bottleneck. On the right, we have the way MOI does it. The same three users, Alice has her own asset tree inside her own participant account. So does Bob. So does Carol. So when Alice sends to Bob, the protocol writes to Alice's tree and Bob's tree, and that's it. Carol's tree is never touched. And here's exactly what matters. Picture Alice sending to Bob at the exact same moment. Carol is sending to Dave. Carol is sending to Dave. The first transfer updates Alice's account and Bob's account. The second updates Carol's account and Dave's account. Four different accounts, nothing in common, so the protocol runs both at the same time. Now that's true parallelism. It's the same lesson as Flipper versus context Flipper from last week. Shared state is sequential, and isolated state is parallel. Last week we proved it with a Boolean variable, and this time we're going to prove it with real money. Hope that makes sense. I'm going to pause for 30 seconds here in case anyone has any questions. All right, if we don't have any questions, I'm going to continue the slides. Once again, if at any point you have any questions, please feel free to drop in the chat. And Vardhan, who's helping me with the session, will just notify me as and when we go. So yeah, so before we touch any code today, I want to kind of give you a quick map of what MOI gives you out of the box. There are four kinds of native assets or four kinds of asset standards built on the protocol today. And obviously, we may have many more in the future depending on specific use cases and templates. We're only going to touch two of them today. One is going to be MAS0. The first one is the fungible token standard. You can kind of liken it to your ERC20 on Ethereum. Just means that every unit is interchangeable, like dollars. So $1 in your account is the same as any other dollar in your account. They don't have identities per se. So this is what you'd use for a stablecoin, for governance tokens, for points programs, for in-app currency, anything where the only thing that matters is how much of it someone has. And the important thing here is that everything you'd want from a fungible token, making new supply, burning supply, transferring, locking up tokens, is all built directly into the protocol. You don't write any code. You don't compile anything. You just tell the SDK, make me an MAS0 asset, and you get one. And that's the demo we're going to be doing first. The second one is the MAS1 asset. You can also liken this to like an NFT. It's the exact opposite of an MAS0 asset. Every token has its own individual identity. One token, one item. You can't split it. You can't merge it. And everything ranges from collectibles, NFTs, profile pictures, art, um, and in a more like broader sense, you can also apply that to badges, digital deeds, credentials, and each one carries its own metadata. And finally, we have not finally, sorry, it's the same. Then we also have the MAS2 asset. Um, so MAS2 asset is an interesting one. It's kind of like a combination of MA0 and MAS1. The best way to explain it is if I take an example of a game inventory. Suppose you're playing some kind of RPG game and you've got gold, wood, gems, potions, weapons, a bunch of things that one would own in the game. Some of them are going to be fungible. For example, gold is interchangeable, wood is interchangeable. Some of the things are unique, and you like to really manage all of them as one single thing. And that's exactly what the MAS2 asset is. It's a multi-token standard. Categories under one asset class, one asset, many subtypes of that asset. It's a mix of fungible and non-fungible tokens built specifically for high throughput cases like games, where you don't want to spin up a fresh asset every time someone adds a new item to the world. Yeah. Also, we'll talk about this in another session as well. And the second one we're going to be demoing today is the MASX asset standard. And this is kind of a different shape than all the other three. The first three, 0, 1, and 2, are fixed standards. The protocol decides what they do. You get what you get, which is great when your use case fits one of those buckets, but sometimes it doesn't. For example, maybe you want a token that takes 5% fee on every transfer and routes it to a treasury. And by the way, that's the demo we're going to build. Maybe you want a token that's soul bound, meaning once it's in your wallet, it can never leave. Maybe you want a whitelist token. What that means is only certain pre-approved addresses can hold that token. None of these conditions fit MAS1, MAS0, or MAS2. MASX is kind of like the escape hatch. Like you write your own routines in Cocoline, MOI's smart contract language, and they essentially run alongside the protocol's native primitives. So you get custom behavior, but the protocol still owns the accounting underneath. You're writing policy, not bookkeeping. So the major rule of thumb to remember here is that use one of the three native asset standards when the built-in behavior fits your use case. Reach for MASX only when you need something that the standards don't already give you. Today, we'll see both ends of the spectrum in Demo 1 and Demo 2. We'll create a standard fungible token with zero custom code, with just one SDK call. And then in Demo 2, we're going to build a 5% tax token in Cocoline. And I also encourage you guys to code along with me as we go in the session, because we have some fun rewards at the end. But yeah, the main point to remember over here is that the separation between the policy and bookkeeping is still something that's very unique on MOI, meaning all operations happen at the protocol level, meaning you can be sure of safe accounting. but you still get to write your own custom policy on top of this. So yeah, if anyone has any no questions, I'm gonna proceed with the demo. We have a quick demo. I'm gonna pause for about 15 seconds here. All right, yeah. So demo one, the MAS zero asset standard, a standard fungible token. Let me walk through this code, and then we'll run it. So the top block, which is the MAS zero asset logic dot create. This is probably the most important line within this program. The it's essentially a function that allows you to create a fungible token on MOI. And the coolest part about this is it's just one line of code to create it. The wallet that it takes in about 5 arguments. One is a wallet that signs. Two is the webinar, so the token's name or the asset's name. Three is the maximum supply, which I'm put as 1 million. Four is the manager's address, which is me in this case. And five is a boolean for whether minting is enabled post deploy. And one important thing, this 1 million we have over here is just a ceiling, not the starting balance. It's kind of like the max that can ever exist of this token. And we haven't actually moved any tokens into circulation yet. That's what the next line is for. This is where we essentially move we move the tokens into circulation. So down here, we instantiate the asset class with the asset ID that we just got. And then we mint 100,000 webinar tokens. And yeah, I'm just going to mint it to myself for this for the time being. But obviously, you can replace address with anyone you'd want to mint to. And that's the actual circulation step. After this runs, the manager, which is me again, will hold 100,000 of the webinar token. The supply ceiling is still 1 million. We just haven't minted the rest. And the thing I want you to notice is there's no like smart contract code anywhere in this file. No Solidity, no Cocolang. We deployed a transferable fungible token in basically 5 lines of code. 5 lines of code out of which only effectively 5 lines of code with only 2 lines that pretty much interact with protocol. And this is something that is not seen in any other protocol or any other chain in the world at this point. And you get this kind of ease of deployment as well as the security and scalability features I mentioned earlier. And yeah, so now what I'm going to do is I'm going to quickly switch to cursor and run this for you. So this is the create function I spoke to you about earlier. 1 line of code, very simple, 5 parameters. And this is the minting function. The rest are all just console.logs just for us to view better. And obviously at the start of every program, you got to import your voice provider, your wallet, your asset class, and instantiate your wallet and the address. Obviously, you can package that into a separate file and just import it, but that's up to you guys, however you want to code it. And it's always important to remember to never share your env your mnemonic with anyone. But before you start any Coco program, or not Coco, any program on MOI, you have to ensure that your testnet your account has enough testnet tokens and that you've imported your mnemonic into the env. So yeah, what I'm going to do is I'm just going to hit node sdk / asset.js. Just got to give it a couple of seconds. And there we go. We've successfully created the asset. We have 1 million webinar tokens. So again, like I said, this is the max supply, but 100,000 is currently in circulation that's been minted to me. So I'm going to copy this interaction hash and go to Voyage just to show you guys that the interactions happened. Yeah. There we go. So operation is, yeah, here's the operation payload. So essentially, we've created the asset. It's an MAS0 type. It's a webinar token. There's a 1 million supply, and here's the asset ID. And we can also see the mint operation that would have just happened here. Yep, there we go. So this is essentially an interaction that shows that the amount has been minted to my account. And to verify that, we can go to the asset playground, which is also such a sick feature. By the way, if I go to asset transfer, select asset ID, and there we go. I have 100K webinar tokens minted to me. If any of you guys have an ID right now, I can also just transfer it to you within 10 seconds if you drop it in the chat. Um, and yeah, so that's essentially two operations both confirmed. And that's pretty much it on the MAS0 side of things. I'm gonna go back to the slides. And keep in mind, if you guys deploy this, if you guys, I'll also be putting up the GitHub link after the session gets over on the Luma, attached to the Luma. So if you guys want to, if you guys would like to follow along and have a look at the code, you can take the code from, I'll be posting the code there. You guys can read it. If you have any questions, you can, play around with it. And keep in mind, also deployment gets you some amount of more tokens, which is going to be great because this is such an easy task, and it also lets you get your hands dirty with more. So I'm going to pause for 20 seconds. I'm going to leave this code up here in case any of you guys want to make note of it, or if you guys want to, if you have any questions, if you want to try to play around with it yourself. All right, guys, I'm going to continue with the next part of the session. Hopefully you guys made note of that. So here we're going to talk about why custom assets and why you need native accounting. So this is something we already touched upon earlier, but I'm going to dive deeper into it. And this is a really, really cool concept as well. Most tokens fit one of three standards, which is MA0, 1, and 2. But sometimes you generally need something that the standards don't cover. For example, a transfer fee, a whitelist, tokens that can't be transferred, which is the Sol 1 token, of course, regulations, and the standards don't essentially cover every use case. They cover the most common ones cleanly and let you extend from there. And that's what the MASX is for. And the design is worth understanding before we look at that code. So on the left, we have the protocol, the protocol's asset engine. This is the only thing that's allowed to actually mutate asset state, balances, and also ensures the entire mandate lifecycle. So approvals, expiries, revocation, supply accounting, and it also enforces invariance. So no negative balances, no exceeding max supply, lockups and releases, everything that lives within the protocol within the context of like rule enforcement that lives, or accounting that lives in the asset engine. And on the right, this is essentially the asset logic. This is essentially what you write in Cocolang. It's the policy layer on top. You answer questions like, when is the transfer allowed? Who can mint an asset? Are there fees involved, and who collects them? And are there any transfer restrictions? Are there any custom mandate rules? You're writing policy in maybe 10 to 30 lines of Coco. So, to summarize, here the asset logic which you write in Coco is the custom policy, custom rules you choose to set, and the protocol asset engine. This is what essentially tracks your live balances, enforces invariance, updates each account's balance. And this is the crucial point, the split. Logic answers, the asset logic answers, is this allowed? The engine answers, apply state transitions safely. You write the rules over here, and the protocol does the bookkeeping. That's why the MASX is short. You're not essentially re-implementing accounting. You're just saying which calls go through and where the math should send the tokens. Yeah, and to add to that point, the same level of safety that you'd get for a protocol-defined standard like MA0, 1, and 2, because purely due to the fact that all transfers, all minting, all burning, any operation, any primitive operation that's involved within an asset transfer is purely handled by the protocol. And this level of safety is not available on any other protocol or any other chain today. And to further show this to you guys, we have a quick policy of sorts that I've implemented on Coco. And so here's the Coco file. We've got 20 lines. Let me walk through it top to bottom. So Coco asset tax token, different keyword from the regular Coco logic we saw last week. Asset essentially means this module is an asset bound. It's a keyword that extends a built-in standard. In this case, it's MASX, and the routines I'm about to write can be called like any other asset routine. So at first, we have state logic, two persistent state slots, the treasury where the tax goes, which is, oops, sorry. Yeah. So we have two persistent variables here. One is the treasury. This is where the tax goes. To summarize what this program essentially does is anytime a holder of this token transfers X amount of tokens, 5% or a predefined percentage of those tokens go into a treasury um, as tax. So for example, if I were to send Vardhan 100 tax tokens, five tokens of those would go into the treasury, only 95 would reach Vardhan. In this particular case, because I'm the deployer of the asset and I'm the one doing the demo, I own the treasury. So you're going to see the balance updated within my my account essentially. So yeah, the two persistent state slots. One is the treasury where the tax goes, and second is tax BPS, which is essentially the tax rate. So 500 of tax BPS is essentially 5% of tax, to put it simply. Um, then we have the deploy of the initial init endpoint, which is essentially a constructor. Um, yeah, so this runs only once when the asset is created and never again. It takes three arguments: the treasury address, the BPS rate, and the supply, initial supply of the token. The two mutates over here, mutate T and mutate BPS, they write the initial arguments into state, and then this line, asset mint, is essentially where all the magic happens. We're calling the inherited MA0 mint primitive from inside a Coco line. The protocol knows what mint mint exactly means. We just tell it who to mint to and how much. So that's the uh yeah. And after init runs, our asset has its treasury wired up, its tax rate set, and the treasury holds 1 million tax tokens ready to be transferred. Then we have our transfer endpoint. This is the interesting one because this is where we're enforcing our policy. Um, yeah, this name is the name transfer is essentially the override. When anyone calls transfer on this asset through the SDK, through a wallet, through another contract, they hit our routine and not MA0's built-in one. So essentially, let's walk through the code line by line. We declared two local variables, the treasury and the BPS. Treasury and the BPS, and the observe line reads them from your persistent state from here, and from this point we essentially compute the tax as amount times BPS divided by 1,000, and that's just regular percentage math because we're storing BPS as 500 instead of 5%. The reason for that is U256 wrapping prevents overflow on big numbers. And finally, the remainder is the net. That's the amount that gets transferred. Um, and then these are the two built-in protocol primitive calls um, for essentially transferring the asset. So one to the treasury, which is this that essentially goes to my account. Oops, I think my screen stopped sharing, guys. 1 second. Yeah, okay. Vardha, can you confirm if my screen is visible? Perfect. Yeah. So as I was saying, I was talking about the two asset transfer calls. So one of them goes to the treasury, which is the tax amount, which I've computed over here, and the other one goes to the other one essentially goes to the beneficiary who's the receiver of this um, amount. So essentially, like I explained earlier, if I'm selling 100 tokens to Vardhan, um, he would only get 95 of those, and 5 would return to the treasury. And keep in mind the beneficiary over here, that's this is just a template. This is just let's say yeah, it's essentially a template. Once we do call the SDK, we can obviously change these up and have different names for each. And I'll show you that in the next slide. Yeah. Oh, I think we have a question. Let me just read this. Hey Sanjay, that's a great question. Let me get back to you on the answer once the session's over. Yeah. But now we're going to be talking about the deployment of the tax token. It's the same flow as before. So now we have the Cocoa file. We need to compile it, and essentially once we get the manifest, which is the tax token.json file, we deploy it to the SDK. So two things to notice up here. First, we're importing Asset Factory, which is a new class we haven't spoken about yet. In demo one, we use MA0 asset logic, and um, that class is essentially an implementation of this. It only knows how to make MA0 assets. Asset Factory is a general purpose version. It can deploy any kind of asset on MOI, including custom ones, because you tell it what you want by giving it a manifest. And a manifest is essentially a set of rules. Secondly, we're importing the manifest itself, and that's the tax token.json file when we run Cocoa compile. It produces this file, which is essentially compiled bytecode plus a description of what routines or what functions exist, what policy, what rules exist within it. So when we hand this manifest over to assetfactory.create, the SDK knows exactly what we're trying to do over here. Um, yeah. So the next thing is, yeah. So I'm going to, yeah. So tax BPS 500. This is essentially what I was talking about. This is the tax variable. This is 500 essentially means 5% in basis points. Then we also declaring an initial supply as 1 million. So we use the supply twice, once as the max ceiling and once as the amount we mint to the treasury inside. And yeah, so let's take a look at the deployment call. So asset factory.create is similar to MAS0 asset logic.create as I showed in the previous demo, except this is general purpose as I mentioned. So the first 5 arguments, one is wallet, which is the person who's signing this transaction. Second is the name of the token. 3 is initial supply. 4 is the address of the owner or the manager. And yeah, yeah, and 5 is whether you want to deploy on mint on like post deployment. 6 is the manifest. So 6 and 7 are the two main different points that exist within um, asset factory.create as opposed to the MA0 logic class. This is essentially a set of rules that allow you to dictate your policy, and that's what we got in from the Cocoa contract. And I'm not just going to show you slides over here. I'm actually going to deploy it and run it so you guys have a clearer idea. And yeah, so I'm going to switch to terminal real quick. So first, this is our Cocoa contract. This is the Cocoa asset tax token as we discussed earlier. We have the two persistent variables, the deployment endpoint with the asset.mint, and the transfer endpoint that deploys that essentially explains our rules. So the first thing I'm going to do is cd into Cocoa and Cocoa compile. Perfect. Now I have tax token.json. Next thing what I'm going to do is I'm going to cd out of Cocoa, and before I do that, let me show you the file as well. So this is the file we were just talking about. Um, just one line of code outside of the initial wallet setup and variable declarement. This is just one line of code that allows you to create this asset. So what I'm going to do is I'm going to do node SDK slash tax deploy .js. Let's give it a minute. Perfect. So this is the treasury address. This is the asset ID and this is the interaction hash. So I'm going to just copy this interaction hash, take it to Voyage. Yep, and there we go. So MAS 65535 is also internally what a custom asset standard is called, but we also refer to as MASX. So yeah, this is a symbol. This is the total supply we declared, and this is the asset ID for that token. Now, what I'm going to do is I'm going to demo actually enforcing the asset rules that we spoke about. So the whole point of this was to show that you can create custom asset logic with the protocol handling the accounting in the backend and handling the bookkeeping, right? So let me actually show you guys how these rules are enforced. So I'm going to go to the asset playground. I'm going to select it's a tax token, and we have 1 million of those tokens right now. I'm going to transfer it to another account that I have, another Voyage account I have set up. So let me go ahead and copy the address for that, and then paste it here. So we have 1 million tax tokens, and if I send 10,000 of these tokens to my other account, we should only have we should have only 9,500 tokens that actually go there and 500 tokens that stay here. So I'm going to try that out. So if I do 10,000 and I hit transfer, sorry about that. Okay, now that's been finalized. Now, if I go to this account and if I go to my asset playground and I check, yep, as you can see, I only got 9.5 tax token, 9.5K tax token, and the remaining 500 would have stayed with this address, the initial address I sent to it. Let's just explore that. Yes, exactly. You see, we have 990.5K tax tokens. So the extra 500 stayed back here as tax. And that's essentially the point we're trying to make over here. You can enforce custom protocol logic by not creating any smart contracts or any centralized, units of liquidity as they do in Ethereum and other protocols. And I'm going to stop here for another 10-15 seconds in case anyone has any questions about this. And once again, guys, please do, give it a shot. Give it a shot by deploying this on your own. It's super easy to do this. It's I'm also going to be posting the GitHub repo online very soon. But yeah, I mean, it's a chance of winning free MOI tokens. It's a very simple task, and it actually gives you a lot of exposure into how easy it is to actually build applications onto MOI. And obviously, at any point, if you guys have any questions, always happy to answer. And yeah, I'm going to proceed with the next steps then. So that's pretty much the demo. It's only 2 demos that you guys have to, essentially submit. I'll talk about the bounty in more detail later. But here's the summary. So let's step back for a second. In the last 40 minutes, we shipped 2 assets, a standard fungible token and a custom asset token, a custom tax token. So let me count what we actually wrote versus what protocol did. So these are things I didn't write. I didn't write the balances mapping, overflow and underflow checks, mint authority logic, the atomicity of multiple multi-step state changes, supply cap tracking, and the entire asset tree state machine that lives inside every asset. I did not touch any of those. All of that was enforced by the protocol. All that came from the protocol itself. I didn't have to touch any of that. What I did do, I did write an MA0 create call. I did write an MA0 mint call. And for MASX, about 25 lines of Cocoa policy, and 3 arguments to initialize it, and 1 asset factory.create. And that's it. The rest is just the engine. That's what native asset means. The protocol owns the state machine. You write the policy, not the bookkeeping. If you take one thing away from the session, take that. That's the most important point. And quick map of where the series goes next. You've seen two of the four asset standards, fungible tokens, which is currency, like you can use it for currency, governance tokens, points programs, and that's what most of your tokens will be. And we've also seen MAS tokens, which is a customizable end. And today we worked on the tax token. In future sessions, we may talk about MAS1 and MAS2 tokens as well. But implementing those is the exact same process as what we showed you today. We have full documentation on docs.moi.technology as well as the JSMO SDK docs. And the fundamentals page on assets is generally worth reading if you want a deep version of what we covered today. Let me quickly just show you guys that as well. I go to docs.moi.technology. And if I go to learn, we have a page basically covering everything we covered today. So assets, definition of asset, what each technical component is, and how it's different from other existing solutions. It's a pretty cool read. If you guys are interested, please give it a read. And yeah, yeah. And one more thing on MA0 we didn't cover today. We focused on create plus mint and the custom logic story. But MA0 has many more native primitives than just those. We have transfer, mint, burn, lockup and release, balance of. You can also like set metadata for individual assets. All of these are on the JSMO SDK docs, which also I can quickly pull up and show you. Yeah. So if we go to interactions, core classes, asset management, and hit, for example, MAS asset standards, you have the list of every single operation that is possible within this SDK without writing a single line of contract code. You can set static metadata, dynamic metadata. You have a bunch of read-only methods. It's yeah. And here's the exciting part. Ship what you just learned. Before I open up any questions, one more thing. The ecosystem team will actually set aside a points program for people who actually go and ship this themselves, not just watch today. Um, Obviously, it's one thing to listen to me talk about it, but it's another thing for you guys to actually get your hands dirty and see what the power is yourself. And here's how it works: 3 steps. So run the demo that we just did. Create your own MAS0 asset and mint some supply. Grab the asset ID that prints in your own terminal and submit on the Google form linked over here. And as a bonus, we also have, let me just pull up the form real quick. And as a bonus, we also have the capability of, we also have a field where you can enter your custom asset logic within the form. So you can create your own custom logic, you can deploy it. And if you upload those 2 asset IDs on the Google form by Sunday, you'll be sure to receive some tokens. And it's it's quite easy and quite fun to actually do it and get your hands dirty. So yeah, the form is attached in the PowerPoint, and yeah, for sure, I'll share the recording as well. The form is attached over here, and it's also going to be on the Luma itself. And the deadline is Sunday. If any of you guys need any couple of extra days, let me know. Feel free to ask me questions at any point. And yeah, that's pretty much it for today's session. Like 3 takeaways is one, a native asset is not a contract, as is a first class. Primitives on recognized by the protocol. Uh, Deploying an MAS0 asset is one line of code. And finally, MASX is your own policy where the protocol handles the bookkeeping. So you don't have to worry about any safety concerns there. Obviously, you do have to worry about safety concerns, but that's obviously putting it broadly. And that's the presentation for today, folks. If you guys have any questions, I'm going to hang around for a few more minutes. And yeah, thank you for joining. If you guys don't have any questions, feel free to drop off as well. That's coming to the end of the session now.